got my math degree, and then I got my teaching degree at Western. All right. So here we go. Gus, need your attention please up here. Want to turn yourself around? Thank you. All right, next section you can see, be patient. Only have 4 slides, not a big deal. Perfect little lesson for a half day. Again with the drama, Peterson. Every day with you, I'm sure. It's your hip or it's your... All right. Oh yeah, that's right. I forgot about that. Sorry. Um, that was rude of me. From one... again, I apologize. From one end of a long segment, you draw an 80 centimeter segment at a 26-degree angle, okay? So here's what we got going. We're going to start with this segment right here and this segment right here, okay? We're learning something new, okay? And hold on just a second, we'll get there. From the end of both of those, I draw an 80 centimeter long line segment at a 26-degree angle. Okay? Are you with me so far? All right. What this is supposed to illustrate for you is that if I start by doing that, then unfortunately there are 2 different ways that I can make a triangle with both have another leg of 50 centimeters. So this centimeters long and I go this way. This one is 50 centimeters long and I go this way, okay? The easy way to think about this is that if you think of this right here as being like a little backhoe and this is the scooper thingy, when the angle of the backhoe arm stays the same, this stays the same, that stays the same. If it scoops some dirt out of the ground, it hits the dirt both right here and right here. When it goes in, it makes this triangle, and when the scooper comes out, it makes that triangle, okay? And so what this is all about is, I don't know if you remember this from when you took geometry, but when you are given a side, and an angle, that does not determine one unique triangle. Do you? Okay, good. Yeah, exactly. If you have side, angle, side, then you're good. Okay? If you have angle, side, angle, then you're good. And those 2 things were, Gus, this one was what we did the law of cosines with. This one is what we did the law of sines with, okay? But sadly, if you are given 2 sides and the angle is not in between those 2 sides, there are 2 different triangles that you can draw. And that's why this is called the ambiguous case, because you don't know. Take your hat off, please, Gus. Come on, man. You don't know which of the 2 triangles you're going to end up with, okay? Okay, so in this case, today's lesson, we're going to actually have 2 answers for each question, okay? Because there's 2 separate triangles that will work. Yes? SAS was law of cosines. ASA is the law of sines, all right? Well, that's the same as SSA. It's just backwards. And usually in math class, when you're given that, you say it as SSA, not ASS, because then it doesn't spell a bad word. But it's the exact same thing, okay? All right, so let's do one of these in triangle XYZ. X is 50, Z is 80, and angle X is 26 degrees, okay? So notice that we are in the side-side angle situation because the angle that we know is not in between the 2 sides. So that means that there are going to be 2 different triangles that will fit this information. All right, are you ready? Let's find the missing parts of triangle number 1. to do this, you do it the same way that we've been doing things in this chapter so far. What can I use to figure out one of the angles in that triangle? Okay, good. So I'm going to go sine of 26 degrees divided by 50 because that's an angle and a side that's opposite of it. Okay, and then I'm going to do, it doesn't matter. You said the angle first, so I put that on top. You want me to flip it around? Okay, I know we've been doing it flipped around, and I was a little surprised that you said the angle first, and I just went with it. And I thought, ooh, somebody's going to be confused by that. I didn't think it was going to be you, because you were the one that gave me the answer. But here we go again. So the side of 50 divided by the sine of 26 is going to equal 80 sine of z. Okay? So that's just the law of sines, right? Okay? So how do I solve that for the sine of z? Cross multiply and divide, so that means the sine of z is going to equal 80 sine 26 divided by 50. Bless you. So what is 80 times the sine of 26 degrees divided by 50? Please remember two things. One is that you need to be in degree mode, and the other is that you have to close your parentheses. Also, Danica, you're surrounded by calculators. There's one there, there's one there. It's okay. Will can get you another one, and then you guys can rudely leave them on the table like you do every day. What? 0.701. Okay, thank you. Love it. All right, that's not angle Z, though. That's the sine of angle Z. How do you find out what angle Z is? Inverse sine. So angle Z is going to be the inverse sine of 0.44. Can I go with 5? Okay. All right. So angle Z is 44.5. In triangle number 1, at least. No. How do I find angle Y? Okay, awesome. You know, Danica, that these things add up to 180 degrees, so you can do it a little bit more quickly. You don't have to do that that law of sine thing again. 26 and 109.5. Okay. All right, so angle Y is equal to 109.5. And then the last piece we need to find is side Y. Okay, here is my suggestion to you. You appear to have a choice right now because you know two opposite sides and angle pairs. Always use the one they gave you to start with, okay? So go back to this right here and go 50 sine of 26 equals, this time we're going to look for side Y divided by the sine of 109.5. Yep. I'll hold on while you guys calculate that and tell me what you get. Gus, can you stop doing that, please? Remember how proud you were last week? Okay, so do you guys recognize that none of what we did in that problem is new? Okay, that's exactly what we were doing before. You just use the law of sines to find an angle, and then you use that and the whole 180 thing to find the other one, and then the law of sines again, right? So we're good? Okay, the only thing that we need to pay attention to now is that since it was a side-side angle situation, there is a triangle number 2. Here's how you find the second triangle. Are you ready? The first angle that we found on this one was angle Z. Okay? And we got 44.5 degrees. Our new angle Z for the second triangle could be 180 minus 44.5 degrees. Okay? So whatever angle you find first, subtract that from 180, and that will tell you what that angle could be on your new triangle. Okay, I'm going to say that again for those of you that are watching at home. Whatever angle you find first on your triangle number 1, subtract that from 180, and that's the new possibility for angle Z, okay? And what do you get from that? 135.5. Okay, from there it's super easy because we can now right away find angle Y because we know that our new angle Z is 135.5. We know that X is still 26 degrees. They gave us that in the original problem. That's never going to change. So if you go 180 minus 26 minus 135.5, no, Gus, no. I'm trying to teach a class. What do you get when you go 180 minus 26 minus 135.5? Is it 18.5? Okay, so that means the third angle is 18.5, and now all we have to do is find side Y. Okay, so I'm going to do the same thing I did down here. I'm going to go 50 over the sine of 26 is equal to side Y divided by the sine of 18.5. And you're going to tell me what side Y is. What'd you get, Claire? 36.2. And we confirm that independently? Okay. Okay, so this piece right here is the only thing that is different. Yeah, and it's much easier than the first one, right? Because you just get the first two angles, boom, boom, and then once you get those, you just use the law of sines to find the other one. I believe so, yeah, Will? Because there could be two, and so we need to do both. It's like if I ask you, if I say, if you know that x squared equals 9, what does x equal? 3, or what? Negative 3. So you're like, why do we have to find both? Because they're both there, right? So it's the same thing with the triangles. Both of those triangles exist out in the big world, so we need to find them both, okay? Yeah. Somebody? No? Okay. Nothing. Yep. Not the other teams. No, they were doing, no, there was something that, yeah.